Good morning. Good morning, all. Due to net problem, we are not able to connected in the right time. I'm trying from the last 20 minutes. The last 20 minutes we are trying, but we are not able to connect. So, you are not. I'm waiting when it will be stable. I will start. Due to net problem, it is not stable. So sometimes it is stable, sometimes it is unstable. It, today again net issue. Place. Don't leave the place. Wait. This problem will be sort out now. Yes. Wait, Jigyasa, you all. Now send one message in your group to join. Send the message to all to join the group. Now the class will start. It is already started, you tell. Shreyas, Kaushik, Rajastri, Pratyusha, you see whether it is visible or not, audible or not. I'm waiting till that stability. I think net is stable now. Now it became stable. So that I can start the class. Ambikya, good morning. Audible. Then I'll start the discussion. Now the number is very poor today. 11 students are now. I think most of your friends left. They thought there will no class. I have given the link. I have already given the link just to circulate the message among yourself so that all will online and attend the class. Now audible. Whether visible or not, whether I am visible to you or not. You check. Now Rajashree, Shloko, Om, Swagatika. Acha, not visible. Wait, Swagatika. I think this net problem will be solved within some seconds. I think. Wait 1-2 minutes more, then I'll start. Today net is not stable again. Last 20 minutes it is problem. Sloko visible. Subhasri again you see and write. Circulate the message that it is visible and audible. If visible and audible, then I'll discuss the matter. Discuss the next relation. Next is your relation. Today's topic is relation actually. I will discuss the problems of a relation. Last time we have discussed about Cartesian product only. Only Cartesian product is completed. Today we will discuss a relation. What the different type of relation? What is the relation? That we will discuss. Subhasri, tell me now. Subhasri Rath, whether I am visible or not, audible or not. Actually, I am having that net issue. It may be with your phone, with your network connection. Problem may arise. Okay, we'll start now. See now. Now most of you have written visible and audible. Now I'm writing. Now I'll start the class. Suppose A is a set. It is 1, 2, 3. B is another set. It is 2, 4, 5. Then another one is given C. C is 1, 3, 5. See now this problem. What is the value of A intersection B Cartesian product C? See now this one. A intersection B Cartesian product C. If A given B given, then you will write A intersection B. A B given here. Intersection means the common elements. Common elements of A and B. Here only common element is 2. So A intersection B is the set containing 2. A intersection B Cartesian product C means here we write the Cartesian product between the set 2 and set 3, set C 1, 3, 5. Now the result is 2, 1, 2, 1, 2, 3, 2, 5. This is our answer. A intersection B given here. Then I'm multiplying A intersection B with C, the Cartesian product. A intersection B has only one element. C has 3 elements. So the number of element in A intersection B into C is 3 into 1, that is 3. That 3 is here. Cartesian product contain order pair when 2 sets involved. When Cartesian product among 3 sets, you will get triplets, order triplets in the bracket. Next, what is your answer? A Cartesian product B intersection C. To get this result, A remains same A. It is 1, 2, 3. Then Cartesian product B intersection C. B intersection C. B intersection C is the common element of B and C. If we check 1, 2, 4, 5, 1, 3, 5, only 5 is common. So here is the set containing only 5. So the Cartesian product is 1, 5, first order pair, then 2, 5, second order pair, then 3, 5. This Cartesian product. A Cartesian product B intersection C. This is a way how to find the Cartesian products. Let us see another problem of this type. Another problem. Same, first you see some more problem from Cartesian product, then I'll proceed with the relation. Suppose A is 1, 3, 5. Set B, it is 3, 5, 7, and C, it is 1, 2, 1, 3, or 1, 2, 5, 7. 1, 2, 5, 7. Then A difference B Cartesian product B difference C. Then I can calculate A difference B, Cartesian product B difference C. This one. A difference B means present in A, not in B. A difference B means present in A, not in B. Means we'll check one is not here, so it is in your A difference B. 3 present here, 5 present here, so only one element, it is 1. Cartesian product B difference present in B but not in C. If you check 3 is in A, B, it is 3. 5, 7 present here, so only one element. Here only one element, here only one element. So the Cartesian product is only one order pair, 1, 3. This is your way how to find. Now question for you. You calculate A intersection B into C. It is for you. A into B intersection C. Then third question, C difference A Cartesian product with B. Work out quickly. A, B, C are the sets. A given, B given, C given. These three sets are given. It is required to calculate this one. Question number 1. A intersection B Cartesian product with C. This one. Question number 2. A Cartesian product B intersection C. Third one is C minus A. C difference A Cartesian product with B. A, B, C. These three sets are given. Use these three sets and solve these three problems. Quick. When I'm writing quickly, today that number of students is less. Till then, we will continue. Now we are continuing very slowly. I think all the subjects. Teachers are teaching very slowly as only online classes are going on. It is not possible to proceed very fast or normal speed. Actually, this is our slow speed, not the normal speed. If completed, you write question number 1, 2, 3 in that way. When you are writing completed, mention the question number. Which question you have completed? Completed. Let us see. Yes, you have completed. Answer not required. Subhasri. Answer not required. Just to write with a complete or not. Now, Swagatika, Subhasmita, Devadatta, Shloka, Etlcham, then Gayatri, yes, Sarmishta, you are present now, Pratyusha, Ambika, Jasmine, Smile, Om Subham, then Sarmishta, you have completed all, very good. Pritam, good morning, you are present, very good. Then next, Jigyansa, Subhasri, Anita Mandal, then Subhra, you have completed. All the three problems you have completed. Prachi, Rajastri, Aman, then Shreyas. Once again, good morning all. Now I'll proceed to the next. As you have completed, is there any difficulty to solve the problems or completed? I think you all have written completed. I'll proceed to the next concept. You see now, next concept. That is the concept relation. We'll proceed to relation. Now I'm considering these two sets. This is set A and set B. Suppose here is 1, 3, 5, 3, 5, 7. That relation from A to B. Suppose R is the relation from A to B. It is given like this. It is given like this. I mean, 1 is related to 3, 3 related to 5, 5 related to 7. I mean, elements of A plus 2, you will get the elements of B. If for elements of A, if I write X, X is the element of A, Y is element of B, then here the relation is Y equal to X plus 2. Is it? That is the relation. Elements of A and B are related in this way. If you write 1, 1 plus 2, it is 3. Then 3 plus 2, it is 5. 5 plus 2, it is 7. This is the relation here. Here, the relation can be written in different ways. The way I have shown you here, it is called arrow diagram. We are representing the relation by arrow diagram. Here I am writing that relation 1, 3, 3, 5, 5, 7. Now the way I have written, it is called roster form, representing the set in roster form. This is your roster form. Suppose I write R equal to xy such that y equal to x plus 2, x belongs to A, y belongs to B. Okay, this is your relation. Same relation is written in different forms. First one is your arrow diagram. Second one is written algebraically, that is roster form. Third one, it is also written algebraically, it is your set builder form. Already you are acquainted with these two terms, roster form and set builder form, in your previous chapter. It is your arrow diagram, roster form, and this one is your set builder form. So a relation can be written in these different ways. Here, the first elements, if you consider the first elements, that is your set A, and the second elements, that is your here set B. Here, that A is called domain and B is called codomain. Domain and codomain of the relation R. Suppose one relation is given from one set to another set. That first set is your domain, second set is your codomain. By taking the first elements of the order pairs, you will get a set. That set is called domain. Taking the second elements, you will get another set. That set is called a range also. Range. Range is a subset of a codomain. This 3 is called image of 1. 5 is called image of 3. This 7 is called image of 5. And this 5 is pre-image of 7. 3 is called pre-image of 5. This 1 is pre-image of 3. So image and pre-image are the words related in this way. Once again I am telling, 1 is pre-image of 3, 3 is image of 1. Here, come back to the arrow diagram. 1 is pre-image of 3, whereas 3 is image of 1. 5 is image of 3. 7 is image of 5. In that way, we are writing the new words. Now you proceed to your book. What is relation? The relation are from A to B is the subset of A cross B. The very simple definition given in a book. Relation is nothing but a subset of A Cartesian product B. A relation R is a relation from set A to set B. It means that relation is a subset of A cross B. Phi is a subset. When you write R equal phi, that is an empty relation. Empty relation which contain no order pair. Any order pair you can take one or more. Any subset of A cross B or A Cartesian product B is a relation. Now you proceed to your book for 2 minutes and see the definitions. What is a relation? What do you mean by range, domain, all the things you see. Again, I will discuss another problem. We proceed to page 34 of your initiative book. Page 34. All the things what I have told you here, it is written with a different example, definition 2, 3, 4, and remark. You see this part. Definition 2, definition 3, definition 4, and remark. Quick. See this much. Then I will proceed to the next. Only just to see the definitions. Quick. I will proceed to the next. R is related from A to B. It is given. See now, A contains 3 alphabets, B also contains 3 alphabets. The relation is defined in this way, A to B. I am showing this with a arrow diagram. Suppose this is set A, B, C. Then B, here, A, D, E. Suppose the relation is given like this. It is only given. Then what is your relation here? What is the relation here? That R is written as order pair AD and order pair CE. In this case, what is your domain now? What is the domain of this particular relation? This relation contain only 2 order pairs AD and CE. If you take the first elements, then we are getting the set A and C. Set A and C. And second one we are getting D, E. D. This set is your range and this set is your domain for this relation. In this case, not equal to write B here in the domain. But if this thing is not given, if relation is not given, only it is defined R from A to B, then you will say A is domain, B is codomain. This A is the domain for all possible sets from A to B. But for this particular one, suppose it is R1. Suppose it is R1, then the relation, its domain is AC and the range is D. But codomain remains same B. Now I will proceed to the next basic concept. A contains 3 elements. Now number of elements in A, it is 3. Number of elements in A is 3. Number of elements in B, it is also 3. Then how many elements are there in N? A Cartesian product B. A contains 3 elements, B contains 3 elements. So Cartesian product contains 9 elements. 9 elements are there in the Cartesian product A into B. If a set contains 9 elements, if a set contains 9 elements, then how many subsets are possible? Then you can write number of subsets, that is 2 to the power 9. This is your concept, 2 to the power 9. So here the number of a relation is the same as the number of subsets. So from A to B, there are 2 to the power 9 relations. So how can calculate the number of relations? Now we will generalize this by taking different elements, generalize this thing. This concept, suppose A is a set, its number of element is P. B is another set, the number of elements in B is Q. Then the relation are defined from A to B. Hence, the number of relations from A to B. Number of relations from A to B is 2 to the power P into Q. Remember this one, 2 to the power P into Q. If A contains P elements, B contains Q elements. If A contains P and B contain Q elements, the number of relations from A to B is 2 to the power PQ. 2 to the power P into Q. Now we'll proceed to solve some problems. Proceed to solve some problems. Proceed to exercise 2.2. You do now first question number 1 and 2. Try to solve these two problems. You try first, then I'll discuss. Exercise 2.2. Exercise 2.2. Question number 1, question number 2. Work out now these two questions. Question number 1, 2. Exercise 2.2. Exercise 2.2. Question number 1, 2. Question number 1. Let A equal to 1, 2, 3 up to 14. Define a relation R from set A to set A. A relation on set A. That a relation is given in set builder form x y such that 3x minus y equal to 0, where y and x both are elements of A. Write down its domain, codomain, and range. Domain, codomain, and range. These things are required. Now we'll see how can answer this one. Question number 1. Exercise 2.2. Question number 1. Exercise 2.2. Question number 1. A set is given 1, 2, 3 up to 14, means first 14 natural numbers. This is your set A, and a relation R is defined from set A to set A. I mean R is a relation on that set, and it is defined in this way. R is defined in this way: x y such that x y belongs to A, satisfying the relation 3x minus y equal to 0. 3x minus y equal to 0. Now we write the relation. I want to write the relation in roster form. It is given in set builder form. We'll write in roster form. Here the relation is 3x minus y equal to 0. Then you can write y equal to 3x. Then write the relation. First, if we put x equal to 1 part here. If x is 1, then 3 into 1 it is 3. So second element is 3. Y is 3. When x is 1, this implies y equal to 3 into 1, it is 3. So the first order pair is 1, 3. Then when x is 2, this implies y equal to 3 into 2, it is coming 6. So the corresponding order pair is 2, 6. Second order pair here 2, 6. Then if x equal to 3, then y equal to 3 into 3 equal to 9. So the corresponding element is 3, 9. If x equal to 4, then y equal to 3 into 4, that is 12. So next order pair is 4, 12. Next, if we take x equal to 5, don't write. If x equal to 5, this implies y equal to 3 into 5, it is 15. This 15 is not in our set A. So this is not required. You can write up to this. The next pair is coming 3, 9 and 4, 12. Okay. This is our relation in roster form. After finding the set in the roster form, we'll analyze. What is your domain? Domain. Domain. Domain means the first elements. Here is 1, then 2, 3, then 4. This is the domain of this relation R. Then range. Range means the second elements of each order pair. Here second elements means 3, 6, 9, 12. 3, 6, 9, 12. Domain is 1, 2, 3. Range is 3, 6, 9. Then codomain. That codomain. Codomain is the set A 1, 2, 3 and so on up to 14. This is your codomain. Now we are getting the complete answer of question number 1. This thing you may or may not write, not required. When x is 5, y is occurring 15. 15 is not in set A. So these are the only elements. Now you do question number 2 and question number 3. That 2 you write, then I'll discuss. Let us see how many of you are present now. Subhasmita, which portion is not visible? Either board is not visible or some part of the board is not visible. It should be clear. You have written not visible clearly. Clearly means the some portion of the board or the entire board. Subhasmita, can you write whether part of the whiteboard or the entire whiteboard is not clear? Actually, if it is not visible clearly means it is clearly net issue. Due to poor internet today, you are facing that problem. Sometimes you will observe video may be paused, sound will come. Breaking sound may come. Okay, today board is not visible. I think it is due to net issue. Okay, I will repeat. You tell me whether question number 1 you have done or question number 2, 3 or which question. Ambika, you have written question number 2 you have done. Very good. Subhasri, you have written question number 2. When you are writing Prachi also, those are writing, write the question number. Actual questions are very simple questions are here. Gradually we will discuss or proceed to the interior of the chapter. Very few concepts are here, but we will do more and more problems from other reference books. Yes, Sarmishta, you have written that total board is not visible today. Okay, I will take care of it. Sometimes it is clearly visible, sometimes it is not visible. See now. Most of the time, I'm trying to adjust it. If not visible means, I think net is very poor today. Okay, you see now, I'm discussing question number 3. It is your question number 1. I'll proceed to question number 3. Question number 3. Same exercise. Exercise 2.2. Question number 3. I'll discuss that one. Question number 3. I'll take maximum 5 minutes more after completing these two problems. I'll close the class. Have patience and listen. A equal to 1, 2, 3, 5. Question number 3. Question number 3. Here the set A is given as set A is 1, 2, 3, 5. 1, 2, 3, 5. And set B is given 4, 6, 9. 4, 6, 9. Define a relation R from A to B. A relation is defined from A to B. This is the relation R from A to B. Relation R from A to B. It is given that x, y such that the difference between x and y is odd. It is defined in this way. X, y such that x minus y difference is odd. This difference is odd. Here x belongs to A, y belongs to B. X belongs to A, y belongs to B. This is the relation given. Write that relation R in roster form. Write relation R in the roster form. You see now. How can you write the difference is odd? We know Difference between two odd number is always even. Difference between two even number is always even. Difference between one odd, one even, that is odd always. Difference between even and odd is odd. So we'll start now with the elements. Here, if we take 1, here I'm writing the relation in the roster form. First, if we take element 1, 1 for difference is -3, you can take it is odd. So 1 is related to 4. Similarly, 1 is related to 6. But 1 is not related to 9. Why? The difference is 8, which is even. Then proceed to 2. As both are even, your answer is even. Here 2, 9. Next is 2, 9. Then 3, 3, 4. Then 3, 6. Then 5, 5, 4. And 5, 6. These are the relations. Can you tell? That is your R. Now the difference you check all the cases. In all the cases, difference is odd number. Difference is odd number. So today what I have discussed, I am summarizing it. Look at me. I'll discuss, then I'll close the class. At this moment, the number present, I think it is showing 29, I think. 29 students are present, I think. See now, today we have discussed one problem related to Cartesian product. Then the definition of a relation, a range, codomain, and a domain, or domain, codomain, range of a relation. Then the way we have to write a relation, that is a roster form and set builder form. A relation can be written in roster form or in set builder form. Then some problems related to relation, and we have also discussed the arrow diagram when we are showing the relation by the help of arrow with two sets, between the two sets, that is your arrow diagram. So these things we have discussed today. You work out the remaining problems of exercise 2.2, and prior to this exercise examples are given. Only 3 examples are given: example 7, 8 and 9. These 3 examples you do, and at last I can say what is the number of relation from set A to set B. Number of relation from set A to set B if A contains P elements, Q contains, sorry, B contains Q elements. I mean, number of element in A is P, number of elements in B is Q, then the number of relations from A to B is 2 to the power PQ. 2 to the power PQ. P is the number of element in the domain and Q is the number of element in the codomain. Then you will get the total number of relation is 2 to the power PQ. This part we have discussed today. Now it's already time. Next period we will discuss the remaining problems of this exercise 2.2, and then I'll proceed to the functions. The next concept function require the relation, but I will discuss some relations which is essential for standard 12 this class. Now I am closing the class. Thank you all. Thank you all.